Good morning. Today we learn about simplex method to solve the games. This method does not have any restriction related to dimensions. So you can also solve the game of 3 cross 4 dimension, 4 cross 4 dimension and other dimensions. So here first we check that the game has a saddle point or not. Here we take two companies as a player A and player B. So first we calculate the row minimum and column maximum, and then maximum in this row minimum is 1 and minimum in this column maximum is 4. So maximum point and minimax point both are different. That is why the game has no saddle point and we can use the simplex method. But the minimax point and maximum point both are positive. That is why we can use the simplex method. Otherwise we can't able to solve this game by simplex method. We can, but we have to simplify our given payoff matrix by applying some operations on it. We see this type of example in our next video. But here, when both values are positive, then we move to simplex method and step 1. Step 1 is that we have to assume the probabilities x1, x2, x3 for player A's strategies and y1, y2, y3 probability for player B's strategies and make the equations. We put here less or equal to sign because player B always want to minimize his value of game lesser and player B always want to gain more than the value of game. So that is why here we put less or equal to sign and here we put greater or equal to sign. You also know that player A is a winner player and player B is a loser player. That is why he always try to minimize his maximum losses and player A always try to maximize his minimum gain. So we also uh, make this equation in algebraic method. So I hope you know. Now we move ahead to step 2. In step 2, we divide these all equations and inequalities by V. That means y1 upon V, y2 upon V, y3 upon V, 1 upon V, and here already V is there. So it makes 1, 1, 1. So here I forgot to write down V, but here is 1 upon V. So please note it down. y1 upon V plus y2 upon V plus y3 upon V is equal to 1 upon V. Now we write it down this term as a capital Y1, capital Y2, capital Y3. Similarly, we also do for the player A and player B's equation. And we make two linear programming problems. But here we can see that the pattern of primal problem and dual problem. So player B's equation system is act as a primal and player B's equation system is act as a dual problem because these rows are act here as a columns 4 1 minus 3 4 1 minus 3 3 1 6 3 1 6 minus 3 4 minus 2 minus 3 4 minus 2. Here mistakenly I write down minus sign, but it is a plus sign. 1x1, 1x2 plus 4x3 greater or equal to 0. So here B is a minimax player. So he want to minimize his value of game. Here 1 upon V. So don't forget to write down 1 upon V. So here B wants to minimize V, but here we have a 1 upon V. That means if this is the problem of minimizing, if we want to minimize his value of game, then we have to maximize this whole linear programming problem because here 1 upon V instead of V. So here I also write down this. If we want to minimize V, then he has to maximize 1 upon this. That means this is our maximization problem. And we solve this linear programming problem by simplex method. I hope you know how to solve LPP by simplex method because you already learned it in your first chapter. So that means maximize y1 plus y2 plus y3 is equal to 1 upon v, which is your objective function, and these all are subject to constraints. So our given LPP is this. We consider player B as a maximized player, and these are the subject to constraint, and try to solve it by simplex method. First, writing this given LPP in a simplex format, that means we have to add slack variables to remove the inequality sign and convert these inequalities into equations. So first we do this. So maximize z is equal to y1 plus y2 plus y3, 0 s1 plus 0 s2 plus 0 into s3. Now we add the one slack variable in equation 1 to remove inequality and convert into equation, and in the same way second slack variable into second equation and third slack variable into third equation, and then we make a simplex table to solve this problem by simplex method. So we make a simplex table from these equations. Here y1, y2, y3 and coefficients of y1, y2 and y3 is 1 in this equation, 1, 1, 1. So we write it down here as a Cj, 1, 1, 1, and coefficients of s1, s2, s3 also 0, 0, 0. Now these are our basic variables s1, s2 and s3, and their coefficients are 0, 0, 0, and all these three equations are here. y1 4, 3, minus 3, 4, 3, minus 3, y2 1, 1, 1. Coefficients of y2 in all three equations are 1, 1, 4. Coefficients of y3 in all three equations are minus 3, 6, minus 2. Coefficients of s1 1, 0, 0, 0, 1, 0, 0, 0, 1. And these are the values, real values at last of the equation. So we denoted it as a B 1, 1, 1. Now we calculate the Cj. Now how to calculate the Zj? How to calculate the Zj? We have to multiply this whole column with this all three coefficient and doing sum of it. So 4 into 0 plus 3 into 0 plus minus 3 into 0. So it's 0. We all know that our initial Zj is always 0. That is why we write down here all 0. Now we have to do Cj minus Zj. What is our Cj? Cj is coefficients of our objective function. So 1, 1, 1, 0, 0, 0, and do minus Zj from that Cj. So 1 minus 0 is 1, 1 minus 0 is 1, 1 minus 0 is 1, and all zeros. Now what we have to do, first we have to choose a maximum value from this Cj minus Zj. But here all three are 1. So we can choose any one of them. Here we choose this one. So this is the entering variable in the basic variable. So it is obvious that if one variable is entering in the basic variable, then one variable from this basic variable is removing the basis. So this is the entering variable is y1. So this is our pivot column. Now we have to calculate the minimum ratio to see that which variable leave the basis. So from that minimum ratio we decide that which variable leaving the basis. Now we have to divide this constant value by our pivot column, that means 1 upon 4, 1 upon 3, and here this is the minus 3. So we have to neglect the minus value in the minimum ratio. Now we have to choose the minimum value from these two and choose our pivot row. So 1 upon 4 is the minimum value. That is why the leaving variable is S1 and the entering variable is y1. So this is our pivot row and this is our pivot column, and where the pivot row and pivot column are intersect, that is our pivot element. So in the next step we have to do one our pivot element. That means we have to make here 1 and these two elements makes to 0. That means we have to apply the row operations about this. So here we divide the pivot row by 4. So it makes it like this, and now we multiply this row by 3 and subtract from this row, then we get these values, and we multiply this row by 3 and add into this row, then we get these values. So after doing this, we have to calculate again Zj and Cj minus Zj. So now what is our Zj? So Zj is multiply this column with this column and do its sum. So 1 into 1 plus 0 into 0 plus 0 into 0. So that is a 1. And 1 by 4 into 1 plus 1 by 4 into 0 plus 19 by 4 into 0. So this equals to 1 by 4. In the same way, we get this first row as our Zj because this is the element 1 and another two elements are 0. That is why we get Zj as a first row of this table. So 1 by 4 minus 3 by 4, 1 by 4, 0, 0. Now we calculate the Cj minus Zj. What is our Cj? Cj is 1, 1, 1, 0, 0, 0. So now we have to subtract Zj, this Zj from this Cj. So we get 0, 3 by 4, 7 by 4, minus 1 by 4, 0, 0. We have to continue this process till we get all Cj minus Zj less or equal to 0. So here the entering, we have to choose the maximum value. So our maximum value is 7 by 4. So y3 is the entering variable, and so that is why this is our pivot column, and here two values are minus, that is why we have to neglect that ratio, minimum ratio. So our pivot element is 33 by 4 because that is the only minimum ratio in this column. So 33 by 3 is our pivot element, that is why we have to make it 1 and another two elements make it 0. So we do it in this table, make it 1 and another 2 is 0, and then multiply this row by what? Minus 17 by 4. So we multiply this row by plus 17 by 4 and add into it, and then multiply this row by 3 by 4 and add into this. Yes, add into this row, then we get this solution. After calculating it, we have to calculate again Zj and Cj minus Zj. So now we calculate Zj by this term, divide this column, multiply this column with this column and do it sum of it, then we get this row, and Cj minus Zj, as we know Cj is 1, 1, 1, 0, 0, 0, then we get 23 upon 33 as a maximum value. So now y2 is entering variable and s3 is a leaving variable. So we have to do, this is our pivot element 161 upon 33. So we have to make it 1 and another 2, 0. So we do it in this table. Now we finally calculate Zj and Cj minus Zj. Then we get all Cj minus Zj less or equal to 0. That means we get the optimal solution. Now we can calculate the value of gain from this equation. These three values this is the value of y1, this is the value of y2, and this is the value of y3. So now we can put these values in this equation and calculate the value of game. So here we can see that the value of game is 4 by 7 for 1 upon v, that is why v is equal to 7 by 4. So from these equations, small y1, how we can write it as small y1? So small y1 is equal to, here we can see that y1 upon v is equal to yj. That means if we want to calculate y1, then this v is go to this side. So we can calculate y1 by capital Y1 into v. So here we calculate the y1, small y1. So y1 is equal to y1 into v, that is a 27 by 92. y2 in the same way, y2 into v, 62 by 92. y3, capital Y3 into v, so this is a 3 by 92. Now how to calculate the player A's strategy? These are the player B's probability of B's strategy and value of game. But now how to calculate player A's best strategy? So player A's strategies we can get from evaluation row and elements under the slack variables from the column. That means this value which we get as a Cj minus Zj in the minus form, these are the value of probabilities of player A's strategies. That means 23 by 161, that is the value of S1. This is our small x1, capital X1, capital X2 and capital X3. So 23 by 161 is the value of x1, 46 by 161 is the value of x2, and 23 by 161 is the value of capital X3. Now we have to calculate the small x1, small x2 and small x3 in the same way in which we calculate y1, y2 and y3. So small x1 is equal to x1 into v is 1 by 4, 1 by 2 and 1 by 4. Therefore the optimal strategies of A and B are this: 1 by 4, 1 by 2, 1 by 4, 27 by 92, 62 by 92, 3 by 92, and the value of game is equal to 7 by 4. So I hope you understand the simplex method for the game. Thank you for watching.